Are we stream? We're on. Are we on Twitch? Come on, Twitch. And Twitch. We're on Twitch. And YouTube. The final hurdle. The final boss. Alright, we're on YouTube. Welcome to Code Hangout number 219. Today we're going to look at some anti-cheat for the counter API. Let me know if you can see the chat and or the stream and or the audio, or if there are any issues. I have started on this a little bit. So basically, I've seen some irregularities reported. Let me see. I think it'll be somewhere. Let's actually just look at this. We have the weekly stats, but we also have something like these counter stats. And basically, James Sinclair said he was watching a particular puzzle and it's number one, and the traffic for the puzzle doesn't correspond with this, and it's basically, you know, somebody's basically just been messing with the API. So I figured I'll see if I can build something to prevent the worst of this kind of spam. But one of the issues is that I don't want to limit things. Well, we don't have user accounts, but even if we did, I wouldn't want to limit counter increments to just people who are logged in with an account. And at the same time, we also have some issues on the server with performance. You know, I'm moving to a more powerful server, but that hasn't happened yet. So I don't want to build something that uses up a lot of storage or a lot of memory or costs a lot of performance. So I was thinking, since a lot of this sort of thing, for example, let me see if we can find. Yeah. So for example, a lot of this stuff would look like this, where I'm getting a lot of counter increments from one specific IP address, within seconds of each other. Now, I don't necessarily want to limit an IP address to one counter increment because, there could be multiple people behind it. It's not very unlikely that two people might be solving the same puzzle on their phones behind the same Wi-Fi, behind a NAT, and on the same IP address. And I'm not really worried about quote-unquote cheating with a few counter increments. It's just this sort of very harsh tens of thousands of increments, right? So I was thinking what I could do potentially is to not look at a day's worth of data. We have 40,000 users per day. That's potentially quite a bit of data to store in memory. And I was looking kind of, the counter IDs can be quite long and so on. But if I have a fixed number of entries that I hold in a sort of rolling cache, so the last 1,000 entries, which could correspond to 5 minutes or an hour of time, and basically say, that's a fixed amount of storage, more or less, because obviously these IDs are different lengths, but at least it's controlled, right? And now I'll say, okay, I'll just look at the last 1,000. Every time one comes in, it gets added to the front and I knock one out the back, right? And within those 1,000, I look at anybody who has more than one hit per IP/puzzle. One IP on many puzzles, I don't mind, I don't really care. If one person adds one count to all puzzles, doesn't really affect the things in the grand scheme of things, right? As long as they can only do it once. But within one puzzle, I don't want them to be able to add hundreds of counts very quickly. So the idea was to basically have multiple levels of this. So the first level, we just look at, more than one hit, and the log data looks something like this. Just saw it here in the raw. We basically just have a date and time, we have an IP address, and we basically just have the counter ID and basically nothing else, right? So then the idea would be to detect so we have a hit coming in on a particular IP address and a particular ID. We will look into our queue of 1,000 such events, or maybe 5,000 or whatever, we'll tune it. If that already exists in this, we don't necessarily ignore it at this stage. We'll put it into a list, into a watch list, right? And that watch list also has a fixed number of entries. And they don't have to be a lot. To be fair, this, as far as I know, has only specifically happened twice in the last 4 years or something. So it's not something that happens a lot. So we could have a watch list of maybe 50 entries, right? Or 100 or something like that, right? And now within those entries, we can log their activity more thoroughly. So maybe each of those entries gets 1,000 entries, each of those guys. Or we don't necessarily need 1,000, maybe 10, 50, or 100 is enough, because all we want to know is that person doing something maliciously? Are they hitting too many counts? Right? And then we just sort of kind of throttle them, right? We'll let them have maybe 5, maybe 10, And then we'll say, okay, you know, you got a timeout. You're going to be in this list for 5 minutes or 10 minutes or whatever. And within that period of time, you can still add counts to individual puzzles, or we might revoke this, right? But you cannot add more than X counts per period of time, right? So let's say 1 count per minute or something, or up to 10 counts or whatever. We'll see. So I don't know yet if that'll be just a queue similar to the first one, or if it's literally a complex structure where we're saying, okay, this person has done this, 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 and this, right? And of course, we want to keep the processing low, so we don't want to have to do a lot of processing for every entry, right? So for every entry, we still have to kind of look into our running list, and we might have to add and remove items. And I was kind of looking at some very basic items. So for example, I don't want to have to loop through 1,000 IP addresses and match them. So I'm creating these simple indexes, which are basically what we see here. So each simple index basically has a list of strings and then a object map to the IDs of these strings, right? So yes, it's technically storing the data twice. And technically we don't need this one. Mostly because we can use object.keys. The problem is object.keys would then generate this list. So I want to kind of cache this list, right? I'm trying to think if there's a better way of doing this so we don't have to store each item twice. But I don't think there is. And it might not. I'm not sure. Can we do... Let me see. Get JavaScript get keys without memory allocation. Is iteration of a property, so an object. Because I'm wondering if we actually need the original list, or if having the index is enough, the mapping of a key to an item. So I don't know if we actually need this list. I think the reason I was thinking about keeping the list is if we have a rolling index. But now that I'm thinking about it, we don't limit it to like 1,000 IPs or whatever. We're going to limit it to 1,000 matched entries, right? Like IP pairs. So maybe we don't actually need this. So let's have a look. So the counter queue, yeah, I'm also doing a bunch of stuff here. So I think internally it would treat all the IPs as integers, just to store them more tightly. So they would, as they come in, they would immediately be converted, and then after that only be treated as integers. Because we don't want to store another, 12, 13 bytes of string when we can just store a 4 byte number, right? And I just have, a backup of some log files that I'm just using for testing. So I wrote a little bit of code that basically just pulls in some of these log files, right? So if we look at this, this here basically loads in a bunch of files. In this case, it limits it to, where is it here? To all the ones that start with 2. And then it basically just slices it to 10 just so we can look at them all and don't, but it'll have a couple of thousand in there, right? And each log entry is basically this as a JSON object, right? Because we obviously then need to also look at the date and time. So now what I want to do is I basically want to create this queue object here. And these things here, I don't need actually. And these separate indices, we might not actually need them. Because I think I was misunderstanding how these are going to get used. So let me just sort of think about what we're going to do. So we have something coming in with an IP and a counter ID. And we want to add this. Right now, we just want to add it to a queue. Is it a queue? Is it a, it's a FIFO. Is that a queue? First in, last out. Because we're not processing it from the front backwards. No, it is a queue, right? Well, it's not really a queue. It's a round robin buffer. That's really what it is, right? So I think what we're going to do is we're going to make it really small, like 3 items. And we got to simulate like a little bit of operation here with a limited subset of these. So we want to maybe say, okay, let's pick, n IP addresses. I mean, IP addresses is a little tricky actually, because I'm realizing that in the real world data, we're not going to have that many, like multiple people solving different puzzles does happen, but not as frequently as seeing one IP address once. While we will see many more of the puzzle IDs, because puzzles tend to be played in blocks. Like a puzzle would get released and lots of people will play the same puzzle, but the same person wouldn't necessarily play lots of puzzles, right? But I don't think we need to care about this for now. So we have our counter queue. So in the moment, I'm just gonna remove all this, right? We're gonna have our push function here. We'll pass in an IP string and a counter ID. Now, do I want to handle the date and time at this point? Because originally I was thinking of this as a more primitive object, but ultimately it doesn't make sense to subdivide things. So we'll probably want to handle the incident detection and so on here as well, but we probably won't call it as a counter queue at that point. So in the moment, you know what? In the moment, what we're going to do is we're just going to make a bunch of functions here. So we're going to do the function add item, right? And it'll be IP ID, right? And then here we'll just have our things, right? So we'll have a const queue, and the queue will be, so we'll have a couple of different objects. We'll have our we'll have our indexes, which convert these to numbers. So our queue will just contain index pairs. And these the queues could be a little bit larger, because I'd hope that most of the, okay, let's have a little bit, before we do this, let's have a little bit of a look at what kind of information we have in here, right? So our rows, if I don't slice them here, right? Let's see how long these will get. So that's 390,000 rows. And if I get, if I use, the little tricks here of getting, let's get the counter IDs out. So let IDs equal, so we'll use the set trick to kind of make a unique list here, right? We'll do that here, and we'll have IPs as well. This will be IP. Now the IPs, will normalize them and we'll filter them to make sure, and we'll map them to integers. All right. And basically what this does is, first of all, because these are IP strings that come out of my logging system, which could include both an IPv4 and IPv6, so it strips that out. And sometimes only an IPv6, in which case we're basically ignoring it for now. We'll deal with that at a later stage. And then we can just look at these things, how big they are, how many we have of each, right? And we can basically presume the join of the counter IDs is our memory size, and this the count of these multiplied by 4 is roughly our memory size, because it's an array of integers, right? Right. So, for example, out of 360,000, we have almost 17,000 unique IDs and around 81,000 IPs, right? So that gets us an idea of, and this is not, that's multiple days worth. So it'll take a little longer. Let's just pull all of that day, right? It's not exactly all of this day, because I think there's an incomplete backup of this data, because I had some issues in May. And yeah, so it doesn't grow that much. So these numbers aren't insanely large. Like this is double, but this is only grew by like 25%, and this grew by almost double, right? So yeah, counter IDs, interestingly, no, that's IPs actually. So yeah, so this was my suspicion. So you have twice as many log rows, you almost have twice as many counter IDs, but you only have roughly 25% more, you have almost twice as many IPs, but not that many more IDs. Hey Keith, I'm all right, thank you. Let me know if there's any issues with audio and whatnot. Okay, so what we then need to do is these two will be indexes, and this will be, and then we'll have a queue, and the queue is basically a list of, let's say, 10 entries. And I'm trying to think, at this point, we probably actually need access to the rest of the log data. Like, it's because we need to track the times when these events happened. And we will have duplicate items, so we can't even index them, right? So we'll just have an array. So the queue will just be an array, and we'll push in one end and we'll pop out from the other, right? So the queue will be an array, and we'll have an IP index, and we'll have a ID index. So we'll have these. There's something rattling nearby. Is this my fan here? Why is this rattling? Why are you rattling? Why is it rattling? It's never rattled before. Don't rattle. Right, maybe some vibration. I just got this thing and I really like it, so I hope it's not going bad on me. Hey, Flinty. No, this is currently for the counters because there's counterfeit numbers in the counter system. For example, this received around 40,000 increments within like an hour in May. So I want to fix that. And I can, and so far I figured, oh, I'll manually fix it. But to be honest, I don't actually have a good backend to let me do that easily either. So preventing them might be doable without like too much messing about and too much risk. And since the counter API is a separate process from the server, I can justify messing with it a little bit without risking the whole server going down because I make a mistake somewhere. So first of all, I want to kind of build a little test scenario and see if I can build it in a way that is very memory and performance optimized, so it doesn't affect the main process too badly, right? So, so we'll have a function which, okay, so we'll actually want to have a full log row here, right? And what we'll do is we'll do something like this. Actually, for const row of rows dot slice 0, 5. We'll do add item row. Row, right? So we'll just say, okay, and let's go back to just looking at a few of these files because there's no point waiting a second for it to load this. So we're looking at these 5 rows and we're pushing each of these into our add item, right? So at this point, all our queues and indexes and whatnot will be empty. So we'll say, we'll basically, well, we'll extract the data first of all, right? So ID would be row.puzzle, or we'll just do this, puzzle ID, ID equals row. No, it's colon. It's colon, right? Is that it, or is it equal? Yeah, we don't need all of these either. So let's just take one day. Yeah, undefined doesn't make sense. I'm blanking on the syntax for relabeling spread syntax. Okay, so that doesn't exist at all. Okay. Is it like this? No. I thought it's with a colon. Or is it the other way around? Red syntax relabeling. Can we relabel? This is not really spread. This is what are we calling it? What's the my brain is completely blank on the name of for this syntax in JavaScript. Are you kidding me? Expressions, variable, object. What is it called? Not extraction. Property accessors. JavaScript variable property renaming. Destructuring. Person name. Okay, so it's colon and the new name. Colon ID. Maybe counter ID. Maybe I completely misspelled that over here, and that's the problem. That's very possible. Here we go. Okay. All right. And then we'll have IP. So ID IP. Okay. And then and we'll call this IP string. And then IP equals normalized IP string, and we're converting it to an integer. Boom. And we'll just do this. IP str IP. Okay, so this becomes that, and that's what we'll internally operate with. Okay, here we go. Now, now we gotta make sure we get our indices. All right, so we'll say let IP IDX equals IP index IP, and then we'll just say if equals undefined, we'll add it to our index, right? So IP index IP equals now you see that's the thing. So to get the length of these, we actually would have to call object.keys. So actually what I'm going to do here is we're going to have a length variable for each of these. We're going to put them in the thing, and this was something that earlier I had put into a structure, since these should operate the same way. But for now we'll just manually do that, right? So this should be index length ++, right? And IP index equals that. And in fact, I think we can just do this. Right. If I do this, what does that look like? IP index. Invalid left-hand assignment. Why is this invalid? So if I do this, right, that works. Let's just do it 3 times. Okay. And then here we can say if this equals undefined. Well, if I do this, right, it should just return A. Yes. So why can't I do this? IP index IP equals IP index length ++. That should work. Maybe we need that. Maybe we need some extra braces. Constant variable. Oh, yeah. These shouldn't be constant. All right. These shouldn't be constant. There we go. So now we can do the same thing with the ID index. So ID IDX equals this, ID, and ID index length. And then we'll output that here as well. Right. So, and then at the very end, I'm just going to output the full thing. We filled in these indexes. Whoop. We have that. And we have the ID index. Let's see what these look like at the end, if they make sense at all. So we have our 3 IP addresses indexed, mapped to unique identifiers, right? And those numbers, I think there are 64 bits. I'm happy to keep incrementing them. I don't think we'll run out. In fact, there's more of these numbers than there's IP addresses, right? And they're just so I mean, since the IP address is already 32-bit numbers, we might not even have to index IP addresses at all. If we're not yeah. So we might actually not have to do this with the IP addresses. It might make sense only with these guys, so we're not duplicating these strings all over the place and searching through lists and all this stuff. Okay, fair enough. So we could just use the IP address straight up. So ultimately, we'll get these indexes, and then we'll add an item to the queue, right? So we'll do queue.push. And I guess at this point, we might as well do that, right? So we'll have, and it'll just be an array. We'll have the ID index. We'll just put the raw IP in here for now. And then we'll put the row dot time or whatever. And I think for now, that's just going to be a string. I don't know if in the long run, it's better to convert it to a date, because the parsing could be quite expensive, right? So for now, we're just gonna do this. Whoops. We'll do this. And at the end, we'll output what the queue holds, just to see what's going on here. Yeah. So we'll have this, right? And eventually our max queue will have a max queue length, right? So we'll have a, we'll have this. Okay, I don't know why I did that. And then we'll have max queue length equals 5, let's say, right? So right now this adds 3 items to the queue because we're only looking at 3. Let us skip the IP index. Let's get rid of all of these, right? And let's add 10 items. Right. So now that gets us a queue of 10 items. And basically, when we get to here, we'll say if queue.length is greater than max queue length, then we'll have dot unshift, I think. Right. Oh no, yeah, we don't want to add the whole index. We want to add the index value, right? And then we'll just do this. Let's do it with 5 items and a max queue length of 2. And then we should see it adds 1 item, adds a second item, adds a third item. Max queue length, queue.length, max queue length, queue.unshift. Queue.shift. I should be guessing I should be doing, yeah. So this one gets popped off, and then this one gets added. This one stays here. Now that one rotates through. This becomes that, and that seems to be working. Okay, so let's make this 5. Let's make this 10. And then this should contain the last 5 items, right? And these numbers, do they make sense? So we'll start with 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. 0 pops off, we get to 5. 1 pops off. 1 comes back on. So let's output the row, actually. Let's turn it into a single line. Right? And now if we're looking here, I'm guessing when this 1 comes back, it's the same counter ID that we've seen earlier. Yeah. Cool. And then the 1 comes again here. So this is what it'll look like when we have the same counter happening multiple times, and it doesn't push onto our counter index, right? And the counter index, So the idea is the counter index should also be growth limited, but we can never remove something from the counter index that's still in here. So it's slightly more expensive. So what we could do is we could grow this relatively large-ish, or shrink it at, you know, every half hour or something, because shrinking it will take a little bit of time. Basically, we'd have to just run a filter on it. Although, you know, running a filter on, let's say, 1,000 or 5,000 items shouldn't actually be that expensive. It's definitely got to be cheaper than, I think, than removing one item each time, because we can obviously remove an item from the queue because right now we don't have reference counts, right? But we could add reference counts as well. So our index could count how many times it's actually being used, and then when we're popping it from, but then the complexity I don't think is worth it. So, you know, let's think of that as garbage collection, right? And we can, you know, I want to run it on real life data so we can simulate it, so I can see, okay, on the average day, the queue grows this fast or whatever, and we need to trim it when it hits 5,000 or whatever, right? Now, what does this do for us, right? What this does for us is that we'll have a list of the most recent n items that we can look at, and we'll always know it's a fixed length, right? Now, there are certain things we can do on this list because it is, okay, it's not indexed, because I was going to say we can just say, okay, give me everyone with that number or item, but it's not actually like that, right? Because we don't have an index referencing each one in here. And maybe that's what we want, right? Because what do we care about? We care about duplicate counter ID. Well, the counter ID is a secondary. First, we care about the same IP address. We don't care if there's the same counter ID multiple times. So we kind of want to index it by this ID, right? So it might be worthwhile to have a live index by those IDs instead of, you know, basically I don't want to have to scan 1,000 items every time we're hitting this, right? So we actually do want an IP index, but the IP index is for something else. The IP index is for entries into the queue. So we basically want to say, the other problem is that the queue rows move. So we don't want to reference an ID number, because then we'd have to modify that number, right? It'll have to be relative to something all the time, which is kind of silly. Basically, I'm just saying, okay, how do we, I mean, we could just link to the queue row, right? So we can say, let queue row equals this. And like little const, queue row. We'll push that in there. And now we'll use our IP index, right? And now we'll just say IP index, IP equal. Now, okay, now here we're going back to if the same IP has multiple items in the thing, in the list already. So we could say if we only care about one duplicate entry, which we probably, like, I definitely want people to be able to push multiple things in the time period. So we kind of care about the IP ID combo. And I keep thinking now, this number and this number, if we combine them, we'd have to use them as a string, right? If we want to use them as an index into an, as an object key. And when we stringify them, then this being a large number is a problem. So then we want to go back to actually adding an IP index here as well. So we can do this, right? And now, with our queue row here, right? And we're now gonna put an IP index in here. So now, you know, we'll have two integers here, right? The time, now maybe we want to have that as an actual number. I keep thinking, if I want to index by these two in the queue, I can't use an array unless I'm okay with scanning the whole array, right? But I don't want to use just object keys either, because we have the first in, first out. We need an ordering for which we need an array. So I guess we need two things that we need to maintain, right? So we'll have a queue index here, basically, right? And then the queue index, we don't have IDs. The queue index references the queue rows, right? So Q index, so we'll have a Q row and we'll have a Q ID. And the Q ID is these two combined, right? So we'll just have something like this. Like this, like that, right? And then we can say, whoop, QID equals Q row for now. And then we can also output our Q index. See what that looks like, right? So our Q index now maps our things to these rows. Do we need to link to the rows? Probably not. We probably just care about this. The rows are mostly for managing our things. So the rows could actually... do they need these two things? Yeah, we kind of do. Right. So now the idea is basically, obviously here we have more items than we want to keep track of, right? And I need to double check that we're not duplicating between here and here. I think we're gonna, for now, we're also gonna parse the date. So I think we can just do, we can do date, right? We don't want to track the whole row, or we'll call it date str, and then we'll do something like date equals new date, date string, right? And then that should just be an invalid date. Okay. Date string, new date, date string. Does that not? Date. Oh, that's why. I thought that should work. Right. So now these are date objects, which are basically just another number. Okay. And now we basically have to start cleaning things up, right? So when we're shifting the queue, we'll also need to unset that item. Except we don't have a reverse index, right? So we don't want to have to search for it. But we don't necessarily have to... wait. Okay, so what I'm thinking right now is we currently use this as our unique identifier. And the reason for that is that the moment this is no longer unique, we want to basically forward these to our collision handler, right? So in this case, we don't actually need to handle this, right? So what we need to do is, before we push a row, and so we kind of want to do this. But before we get to the row, we first want to check. So we want to say if this is not equal to undefined, we'll do a collision at QID, QIndex QID. And that will tell us which row already has that match, right? And the collision should happen somewhere over here. If QIndex is not equal to undefined, we have a collision, which I'm misspelling here. So this tells us we don't have a single pair. Okay, that makes sense actually. So look at it. Excuse me. Let's look at this file because we know that file, that particular file, has a has collisions. It might not have collisions within the rows that we're looking at. So let's see where this cheating started. Wait a second. What was that? Okay, so there's somebody's. Okay, that's probably just some bot looking for all sorts of security gaps. All right. Yeah, that's the other thing. I could potentially also look at IP addresses from these things and kind of just block them, right? But let's go back to our attacker here, Mr. 30 something 120. Where is it? Where does it start? Come on. tell you what, let's take this IP and we'll search for the first occurrence here, and we'll get to where it starts doing it a lot, right? So this is row 32,900 something. So let's look at where we're slicing. Here we go, 30,900. So 32,900. 33,910, right? And yeah, we're here already in the middle of the spam, so we want to go a bit earlier. 32,900. 32,900 shouldn't be in the middle of that spam yet, unless it's pulling one file, which is the same. Is that the same file? One sec. I'm looking at the wrong editor here. 21. 0521. Yeah, we're looking at the 05. So this is the 21st of May. And we're in the middle of the bad line number. So I'm wondering if my line number slicing here is incorrect somehow. If I output the row, yeah, we can actually do this. I can just take this string here and search for it, and it's right in the middle at 33,677. So there's probably earlier on, there's that filtering because of the 404s. Yeah, because I'm filtering the 404s. So there's enough 404s to push this forward by like 700. 33,600, yeah. So we need to add 700. So 33,600, 33,610. No, we need to push it backwards by 600. So that'll be 300. And we might have to go a little bit more because this is just super rough and arbitrary. So 31, yeah. So here we have already the attack sort of starting, but we still have a couple of others mixed in. So hopefully that'll give us enough to work with. Yeah. So here we're now getting collisions. Okay. Yay. So when we have a collision, this is basically when we want to hand things over to level 2. We're going to say, okay, this guy goes on the watch list, right? Now, once they're on the watch list, I don't know if we want to continue tracking, like if we want to still cycle them through this particular queue. Well, I guess yes. I guess we'll, because what I'm thinking about is there's no point having the queue filled up with 1,000. But it doesn't matter because it doesn't fill up just with those. Anybody who's operating currently goes in that queue. But I guess we could say if there's already being tracked, we don't actually need to add them to our queue. We can just skip through that. So in the queue, we don't actually care about the dates and times. We'll just need to have them later. So this part, if we're literally just detecting a collision between two hits, and at this point, if we're not acting yet, if we're just saying, okay, now we're gonna watch this guy, and then once they're on the watch list, a completely different system says, okay, everybody on the watch list, we're actually looking at the log date and the dates and times. So you get the first hit for free. It just puts you on the watch list, right? Yeah, I think that makes sense. So basically, in this case, we don't do anything. We'll quit out, right? So we don't do that. And we just return. Right? Now let's see what that looks like on the queuing. And let me silence this for now. And then in this queue, we don't need the date either. So we can skip all of that. Skip that. I don't know if the queue row we still need, right? Oops, I think I got rid of the wrong things. Right, we can do this. Date is not defined. Yeah, we don't need that. The queue row, do we need the queue row at all? it's literally just to maintain ordering, right? And we don't actually care about these individual items either. So this literally is just a, yeah, we've seen this in the this guy exists in the queue, yes, no, right? Basically, the index is just so we don't have to run an expensive index off every time and loop through the array, basically. And the queue is so we can remove things from the index, right? Yes, okay. So if we have a collision, we don't do anything. If we don't have a collision, we don't actually need a queue row here. We're just gonna do this. And this is just gonna be a Boolean, right? And we're just gonna make this a 1 or whatever, right? Actually, a set is enough. I don't know if a set is more performant. I don't know. That's something maybe I'll look into. So we don't need a queue row at all. We need something with slightly fewer collisions, because these collisions will not let the queue run up. This is our queue. So queue has 4 items in it. So if we go a bit earlier, another 100 earlier, we need something where we have less collisions, right? Yeah, so we have a handful of collisions here, but the queue length max queue. Okay, so here we go. Console.log queue limit reached. So we should hit the queue limit at, which is I think 5 at the moment. We have queue limit reached here, and we keep going. And we have the queue as an array of our indices, and we'll have the queue index. Ciao, guys. We'll have the keys here. Queue limit reached. So let's just say queue, and then queue index. Right, and they should look similar. Yeah, in fact, they look identical until our ordering changes. Now, when the queue limit is reached, we need to remove the first item, and we need to unset that in the queue index, right? So if we unshift this here, what's the result? Is that the index or the value? So queue limit reached, it basically pops that off our thing and it returns the item. Okay, so we basically want to do queue index dot delete queue shift, right? So let me I want to indent the queue index just to make it easier to see. Right, so queue index, queue index, queue index, queue limit reached. Queue.delete is not a function. Wait, queue index. Oh, no, we want this. I don't know if delete is the fastest way to unset something from an object. We might want to change this to a set later on. So queue limit reached. Yeah, so they stay the same length and they're basically in lockstep, which is kind of what we want. The only reason we're keeping the queue itself and duplicates of these numbers is that we don't have to do object.keys and linear searches, right? But otherwise, these two lists should basically be the same, except queue index might be, we don't care about the ordering. The ordering might change. All right, let's go down here, do this. And let's do this, just so we know what's the final sort of summary. Now, we have those things. We're not going to worry about those for now. Those just give us these unique numbers for each of them, right? And the numbers always increment, yes. I'm tempted, I'd like to run it for more items, right? But anyway, now, when the collisions happen, we're basically saying, hey, you know, we're just flagging the collision. We're not modifying our structure because we don't care, right? This guy is in collision. I don't think... I guess the only thing that might make sense is if the collision is further in, to push it back to the front so that whoever is currently on the docket gets moved back to the front of the list, right? But I'm not sure if it's actually worth the array manipulations, right? Because for them to get off the list, we'd still have to iterate through whatever, 1,000, 5,000 items, which is designed to spend some time, which means somebody could only cheat once every half hour or something, which is fine. If they increment every puzzle they want once every half hour, problem solved, basically, right? And I think we're about as operation efficient as we can be at this level, right? Now we gotta have the second level where we're basically having a watch list, right? So now we'll have a watch list. Now the watch list would also be based, no, the watch list would be based purely on IP, right? Because we want to punish IPs. We don't care about the puzzle items. And the watch list allows us to do something slightly more complicated, right? And the watch list gets reviewed only every time we have a collision. So we don't have to do this on every API call. That's the saving thing, is that this list should be much smaller and which should happen much less frequently. And we see the only reason here is happening because we're specifically looking at an area of interest. Yeah, so let's see what that would look like. So the watch list, I mean, we'd still want it indexed, I guess, but it could be a relatively short list. It could be like we're watching 50 items, right? And we want to look at maybe... Like, we don't want to look at a lot of items per player because, yeah, there's only so, like, we don't care about people who somehow solve 1,000 puzzles in an hour. I don't, you know, and if we lose some counter increments from that, I don't actually care. So probably 100 items might make sense. We'll have to look a little bit of what the different numbers would mean, because currently I'm thinking about doing it as a fixed memory rather than a specific time. So on quieter days of the quieter times of the day, we'll be able to actually look at a longer time span, which is fine. Fixed memory usage, I think, makes it much more safe, which is, I think, more important. And this is not a perfect solution. It's just a massive improvement. That's what we're looking for, right? So for now, we're just gonna do this. The watch list is gonna be keyed by IP. The IPs we can pull from this thing. Right. Queue limit reached just does that. Okay. So then we'll and then we'll just say watch item. Now, watching here, we've done a bunch of pre-processing. So we probably just want to pass the row in there, right? But we can already pass the IDs and the IPs, right? So we'll have ID, ID, IDX, IP, IDX, row, right? And then we'll do watch item. It's ID IPX, IP IDX, whoops, and row.date. Right. And then here, watch item. Put these three things in there. Console, and this would be date. Boom. Or date SDR. Right. Except I got something wrong. What? What did I get wrong? Read filter dear unexpected. I must have double clicked something. And except it's down here. Oh, okay. Somehow I double clicked that and then didn't realize it. All right. Okay, so here we get a watch item, queue limit reach, watch item, right? So now the watch items, yeah, they have the different times, right? And we basically have for each watched IP, yes, okay, so watch list is actually this. Now we'll probably need a way of clearing these watch lists out as well. So they probably need to be timed out, or we have the same thing, like we'll watch, well, we said that we'll have 5 people that we're watching, right? So we'll basically do this. We're going by IP, right? So if not watch list IP IDX, right? We'll do equals, and it's going to be a blank object like that. And then if not watch list ID IDX, now this is going to be an array of times, basically. And then else, and now here we're just going to output this. If, wait. If we don't have anything on this IP, we're adding an array. If we don't have, yeah, and then this will become an empty array, sorry. And then this gets the date pushed onto it. And then we can do analysis on this array. That's basically what we care about at this point. Now we can do other things. We can say, okay, if somebody hits different puzzles very quickly, we can, you know, we can do some logic to say, okay, this guy gets a timeout or whatever, right? And that's basically what we're gonna, that's the other information this watch list will then contain. For now, it's just gonna be an index into an index of puzzles into an index of dates. And let's just gonna do this a little bit. We'll do this and this. And then we're just gonna do that, right? So for example, yes, IP4, ID 5, in this case gets 1 thing in there, then 2, and so on. Now I'm wondering if we could start this earlier as part of this, and then, but I think this is optimized to have something happen every round, because I was thinking like, okay, we're missing out the very first date time, right? But if we say, okay, we don't care about the very first one, we just penalize from the second onwards, or at least we care about the second onwards. Basically on the third one, we'll say, hey, if the third one is very close to the second one, we'll ignore it, right? Now the dates aren't necessarily in order. So we'll have to think about exactly how we're going to deal with that. We might sort them, but we have more time because this shouldn't happen as often, right? If I do map dt to dt.value off, it should just turn it into integers and it'll look like that, right? Now, if I say I don't output these two here, so we're reaching a queue limit here, and where we're basically deleting from the index and we're unshifting from the queue. That's fine. We don't actually need, that's not a big deal, right? And now we have 1 collision, 2 collision, and for each collisions we're getting an item here, right? And then at the very end we can just say watch list, right? Now it's actually unlikely to have more than 1 item on the watch list, but that's kind of what I'm counting on to see now. So if I'm running this over more items, you know, what happens, right? So right now we're limiting it to this range. But let's say if we're adding, 10 more. If I just do this plus 50, right? And this is what happens. All right, let's not output this here. See how many collisions we're seeing. Okay, a bunch of collisions, a bunch of watch items. Each collision is a watch item, so we don't actually need to log that out separately, right? And then basically we say at the end, okay, we get this. So now every time a watch item comes in, we can now say, okay, if this list is more than X, we don't care, we ignore it. If it's particularly bad, we'll do some things. Maybe we'll ban them even from accessing puzzles, all sorts of things. Now, what this doesn't tell me is how I'm going to back this list off again, right? And I don't think I have good test data for multiple such things. Let's, so I'm trying to think if there's an easier way of limiting this size of this. Let's see, dot keys dot length. If I do this, that'll tell us how many people we're watching. Yeah. Object dot keys. Sometimes my brain just completely forgets some basic stuff. All right, so we have the watch item calls. Let's hide those as well. So we have watch list 1. But what if we do we do watch list dot entries dot map, and the array is IP and ID, right? If I do this for now, it looks like that. Okay. The ID is an object as well. So if we do these, object.entries, IDs.map, and now that is ID DTs for the date times. Well, let's make this slightly saner. Right, and then here we want to have basically ID and then just dts.length for now. Basically, I'm trying to think, is there an easy way of turning this into a simpler string? If I say ID colon this, boom, right? And then we'll just say dot join like that. Why is this in another array? It's double wrapped. Okay, yeah, because this is the IP. So we can actually IP index. We can turn this back into an IP. Not exactly. Ultimately, we can. No, we can't. Yes, we can. Wait. I think we can, right? The IP index has that data in it. Yeah. Okay. So basically, we'll do object dot object. Okay, doesn't matter for now. But basically, yeah, we can reverse look up the IPs by these IDs. Okay. So this is relatively little data. So we can maybe hit more of these. a larger number of these and see if we get a larger accumulation. So if I don't slice these at all and go through all of them, we'll eventually hit a problem. Okay. All right, that problem is in our lib file place here. And it's in ipstring.split. So this will be a try catch error, and we're just going to rethrow it. But we're going to output that ipstr. Line 61. Return. Cannot read properties of undefined. Reading split. Yeah, shouldn't that get caught in the catch? What? Type error not caught in catch. What am I doing wrong here? Oh, I'm an idiot. It has been caught, and then I'm rethrowing it. IP string is undefined. Okay. Try catch. Oh, geez. Embarrassing. We'll just rethrow here as well. And then console to log row and IP string. Try catch. Now this is probably not gonna work. We'll probably need to do this and then that IP and that. All right. Yeah, const executing things in a const messes with error handling, and then using the const down below. So this should come back. It should have been filtered earlier. But I guess I haven't done any of that filtering. Okay, so we basically have to filter that here. So we have to run the normalize first and then filter by the output. So our normalize here comes back as undefined. Oop, I did not mean to do that. Let me just redo that. All right, so we gotta normalize that first. So normalized IP equals that. And then if normalized IP equals undefined, return false. And then const IP equals that of normalized. And we'll call that normalized IP string. And then we don't need that. Right? Hey, there we go. So we are now looking at these numbers are rows. All right, let's just do that. Am I even using these IDs? Not really. So we're just going to do that for now, right? So we're looking at 77,000 rows, and we end up with these watch lists. So we can now say, okay, one or two people are, sorry, this person managed to get on the watch list for 2 items. Yeah, and now I'm kind of bothered that I'm not able to reference the previous row. Let me think. Is there an easy way of doing that? Even just for now, for debugging outputs, right? I mean, I could go back to storing both of these. How am I looking at? I'm using Q shift. So what if I put an array in here, right, and put the row, and then Q shift, and I just take the first element, everything should still work the same, right? The queues are going to be a little bit more complex, but it now means that when we're adding a watch item, and that's happening a lot of times, but for one of these, can I eliminate this guy? Yeah, I think so. These happening earlier on, if I look at these IP IDs, right? So if I limit the rows where I'm doing here, slice, let's say 0 to 10,000, just doing it for the first 10,000. Yeah. So we get a total of a couple of collisions here. So I can just, every time we have a collision, we can potentially, so first of all, we can output something, right? It's not going to be that many. Yes. Now what we can do, we should be able to look at the queue item, which, okay, right now it's not accessible here, so we could just search for it, I suppose. Q.find or filter if there, in case there's more than one, and that'll be ID row, right? And then ID equals ID IDX, right? No. Q ID is actually like that. ID. Oh, that's annoying. Okay, split. Split 0. And the ID index is a number, so I might have to parse int it. Parse int. Boom. Yeah. So whenever we get a collision, we can now see the original row. Actually, at this point, we already have a QID, right? So we can just say where ID equals QID. Although, I think, no, we're fine with doing collisions only on the QID. Sorry, let's get rid of this for now. So we have all these collisions here, and when the collision happens, we have 2 items, right? So we want to do, this gives us, so let me output the collision, and then we'll do console.log row A. Boom. And then row B is the current row. So every time we have a collision now, we should be able to reference the previous row. So we can verify the IP is the same, the counter ID is the same, the count is different, and the date and time is not too far off. So I'm guessing what happened here is this is just standard stuff where the detection didn't work correctly and they messed something around with a puzzle, because this is 3 minutes apart, no, 3 seconds apart. So maybe they'll just clicked again. So this is the sort of thing where I don't think somebody's messing with the system. I think somebody was looking over their puzzle, submitted again, and somehow their local, because the check that doesn't resend it is local on their system, and the local check somehow failed. Maybe they were out of storage, maybe they were in a incognito window, maybe it was on 2 different browsers, right? Maybe, I don't know, right? So let's have a look at some of the other ones, how close they are to each other. Also, why is this an object and this an array? Oh, because we want to do this, right? Yeah. Oh, no. We want to do... wait, what? Wait. The filter will get us a list of things, which we generally expect to be 1 element only. So actually what we want to do, find, which gets us 1 item. And that 1 item will have 2 elements, and we care about the second one. Okay, so now row A and row B are the same depth. So this one, for example, is a millisecond apart. So I'm guessing that's just a double send for some reason. And it's a bad ref as well. So those aren't getting incremented anyway, so we can ignore those. So we really want to only look at action equals increment, first of all. Yeah, so this is all localhost stuff. So these are people messing around on their own systems. Interesting that it's HTTPS localhost. Probably writing a script, maybe trying to mess around, you know. And you see this is within less than half a second. So this is probably where they were testing and realizing that I'm looking at the referrers. Fair enough. So this is also a suspicious ID to look at. Although, I don't think, if it's not on this list of top 200, which it isn't, maybe they're just testing on something, right? This one, yeah. So if it's within a second, I presume it's just a browser error, basically. Ooh, where'd that come from? Oh, touchscreen. All right. So I'm just kind of manually sanity checking my theory. 5 seconds difference, yeah, definitely that. Okay, so I think it's safe to say that we basically want to block anything that happens on that list. Now, yes, okay, so the second step is that once somebody is on the bad boy list, on the watch list, they're gonna stay there a bit longer. So we don't want to have them rotate off the once they're on the watch list, we don't necessarily want to move them off this, right? In fact, they automatically don't, right? Because once we have a second hit, the queue doesn't advance. No, but other things might still push them off the list. So we wanna how are we gonna do that? Because yeah, so I think what we actually want to do is, once they go on the watch list, we're actually going to remove them from our initial queue. And we'll check the watch list separately. Right? In fact, we'll check the watch list first. Because if they're on the watch list, we don't care what happens in the queue, right? And we don't care if they're getting moved off the queue. And in fact, that's kind of what we're doing here, right? No, here we're looking at the queue index. So first, actually, we want to check the watch list, right? So the watch list is currently done by IP IDX. Okay, so we basically, before we do any of this other stuff, here we're gonna say if watch list IP IDX and the question is, if somebody's on the watch list, do we want to block other puzzle increments, or do we only block a particular puzzle increment? Because we could say, hey, you know, that person has done something shady and they're just currently banned from increment encounters at all. Except that, you know, a lot of this sort of stuff would then get caught out. So, yeah, so I think at this point I need to kind of decide the specifics of how I proceed with specific events, right? So for example, if I have an event like this, I want to ignore the second one, but they don't necessarily have a bad penalty yet. So what I would imagine is that we have a penalty number, right? So let's think about this, right? So we'll have something like a penalty, right, where level 0 is basically just ignore increment, right? First match, ignore increment, right? So this would hit penalty 0. So we're just ignoring the increment. And this is basically, and I'm trying to think if I should ignore, yeah, so we have different levels of penalty, and we need to decide when we're moving to the next penalty, right? So for example, we could have a counter. If this happens 5 times, we go to penalty level 1, right? Because at this point, we're already preventing the problem, more or less, because we also need to decide how they're going to get out of it, right? So we basically want to have a timer. So once they get on the penalty list, they have a bunch of properties. So for example, in this case, they'll have a date and time when they got on the list. And then we'll check if, you know, the next time something happens, or if the list goes too big, then people whose timer is beyond a certain period gets removed from the list, for example, right? So we'll have a fixed penalty list of X items, right? Or yeah, that list could be fairly large. So somebody might stay on that list, you know, stalely for a long time. You know, hey, in 5 years, maybe there's only 10 people on the penalty list ever, right? But if I'm going to hit a lot of these, and from this quick test, it seems that there's quite a few of these, right? Then it could be maybe 20 items per day, you know? Now and 20 people, basically, because those 40,000 were all in one IP, right? That's the sort of thing we want to get really, really aggro on, right? I'm kind of torn if I want to penalize people across multiple puzzles. So if somebody has done something many times, we're just ignoring everything from that IP for a while, right? Half an hour or something, right? Rather than just ignoring actions on a particular puzzle. Or if we're always going to do puzzle IPs separately. Because I'm kind of torn between extending the penalty beyond the specific action, i.e., you know, trying to cheat on a particular puzzle, extended to that person's ability to increment any puzzle, versus potential problems with false positives, right? So if one person or one group, one IP address gets blocked from one particular puzzle, it's not the end of the world, because if there's multiple people behind it, and one IP address could be many people. It could be a classroom, it could be a whole university campus, right? It could be all sorts of things. It could be a conference room all behind the same NAT, right? So I think we want to be a little bit cautious there. So, okay, let's think. So first match, we ignore the increment, and maybe they stay on the watch list 5 minutes, right? Let's say timeout 5 minutes, right? The question is, how many times do we count up before we get into the next thing, right? what we could do is we could refresh the timeout. The timeout could be relatively short. And maybe if they do something 5 times with a timeout of 1 minute, then they go into level 2, right? All right, let's do this, right? First match, ignore increment, timeout 5, ignore increment, timeout 5 mins, 5 hits, right? Then we go into level 2. So level 0 is basically when nothing happens, right? There's no timeout. First match, ignore increment, and go to level 1. Plus level 1, right? So level 1, we have ignore increment, timeout 5 minutes, and up to 5 hits. 5 hits, level 2. Right? So the first match already gets ignored, which means, you know, within that queue, we should avoid these kind of duplicate increments, right? Which shouldn't be happening in the first place. So, you know, there's already a whole bunch of puzzle increments. Well, a whole bunch. I mean, we saw this earlier when I did the analysis. It isn't actually that many, right? To be honest, I'm less concerned about harsher penalties, and I'm more concerned about making sure people who are trying to break into the system get locked out for longer. Although we also still have the same problem that they might lock out, you know, this might be a student in a university, and they might lock out the whole university, right? So I don't think we need to go too bad, because if somebody, let's say if we do it, if the maximum penalty is half an hour, if somebody can increment 48 times per day with a script, it's still not going to impact. He's going to bring very low puzzles up a little bit that won't matter, and very high puzzles, it won't make a difference, right? And if they do it ongoing for years, you know, it's something else, right? So, do we actually need more than 1 or 2 levels? Because we could literally just keep it simple and say, you know, these guys are just on a half-hour timeout. No, okay, the problem with that is that, you know, this could literally be 2 different people playing the puzzle together, you know, streamers that are playing on different computers, solving it together, and it should get 2 increments. And yes, it could be within a second, right? So it's fine that, like, we'll allow this a couple of times, and then we'll go up. Right, so first match, we just ignore the increment. We go to level 1, they get added to the list. Now, on that list, they get a 5-minute timeout, so if we run out of space for the list, we'll just remove everybody that's exceeded their timeout. Otherwise, we reset the timeout and we increment a counter. When the counter hits 5, we'll go up a level, and really all that means is the timeout becomes 10 minutes, I would say. So then timeout becomes 30 minutes, and it just gets refreshed. And they can stay on that list forever if they want to. Does that make sense? Yeah. Because if it's a classroom or whatever, that timeout gets hit overnight or in the next break for the next class, and then they're back to normal. And maybe the hits can be a bit more, like 10 hits. I'm trying to think, like, to allow a medium-sized group that's behind the same IP address to play a puzzle and have all their solves be counted. For example, a teacher, and in fact, I'll pass this to some teachers. If a teacher creates a puzzle with 0 solve counts and has a class solve the puzzle, and they're all behind the same IP address, right? So maybe more than 10 hits? Or make the timeout shorter? Like a 1-minute timeout? So maybe 50 hits? And then this would be, I think, per IP plus puzzle ID. So if we do this, 5 minutes, 50 hits, and then eventually we'll get to a 30-minute timeout. Right. So let's think about what that'll look like in our system here. And we'll probably want to start encapsulating, because this is actually pretty close to functional. I mean, obviously, this whole thing needs to be wrapped up in a simple call that then returns yes, no on the increment, right? It should just say, are we allowing the increment or not? And it should be an object that we're just sending some configuration in there. And then the watch list. So I'm trying to think, do we care about the date and time in this situation? Not exactly, right? What we care about is if the item on the watch list hasn't expired yet. Right. So the watch item here needs to be a little bit more complicated. Let's go back to just running like 10. Huh? Where is that? Did I? Oh. Yeah. If I do 100, nope. If I do 1000, nope. If I do 5000, yes. So if I do 2500 to 5000, yes. 4000, no. Okay. 4000, sorry. 4000 to 5000, yep. 45, yep. 43 to 45, no. 41 to 45, no. 4000 to 4100, yep. 4050, good old binary search. 50, 75, oh, no. 4100 again. All right, well, that's 75, 4100. So that's within 25 items. Okay, so here we get 2 hits for the increment call. So we also want to check here if, yeah, we don't need to check for the increment for now. So we have a collision here. We don't care about these. We do care about our watch item calls here. And I think we can go back to ignoring IP addresses. I think. In effect, we're checking for the QID here. So we don't want to pass these in separately. And we don't actually... I was gonna say, we don't really care about the date and time here, because we can just have our own tracking of time here. Once the situation you've described is potentially with full deck and missing a few cards, would it be worthwhile reaching out to them? Yeah, I'll do. That's exactly what I'll do. But I think something like this is actually super lenient, because it says, okay, from the same IP address on the same puzzle, we'll get 50. But it blocks the increment from the first thing. Because what I could also do is I could make a timeout pretty short. So I could say a 1 second timeout or a 5 second timeout. Because people solving within 1 second is very unlikely. Like, even if they're all putting in the digits, following a teacher who's putting it on the whiteboard, right? And generally it's mostly, and you know, if one person is solving and 30 are just copying, I don't know if I want to increment the counter, right? If they're solving on their own, they're probably going to be off by a couple of seconds, right? So we could make this, no, we could make one with a very short timeout where we don't have an ignore yet. The only problem is, yeah, so, okay, so there's a difference. The timeout is to get off the list. But if we say we'll stay on the list, but we have a difference between being on the list and having your increments ignored or not. The problem is I'm also thinking about maybe solving these problems, because these problems are relatively unlikely to be multiple people. They're more likely to be issues on their browser where it just doesn't register that the increment has been made. One of the solutions I was considering is to have like randomized IDs, but obviously for a like, you know, just having my software generate its own ID on the browser. But it doesn't really help, because, you know, cheaters could use that as well to basically just fake, you know, if I don't, instead of using IPs, if I use user agent could be something. Now, user agent, I'm not really looking at here because that's not in my log files, but I'm not limited to what's in my log files, right? So if we're looking at the API server here we have access to other headers. Except nowadays, they're not really super reliable, because a lot of intermediaries strip the headers, right? Because I was going to say, oh, I could use user agent. It's unlikely, but then in a university classroom, it's also likely that they all have the same browsers and probably update to the same versions, right? So I would loathe to rely on other things. And I'm okay with counting fewer hits, to be honest. In the future, once we have registered users, I would expect classroom situations to have user registrations, right? And then, you know, then these things wouldn't apply at all. This would be only for anonymous users, right? It's just right now all users are anonymous. The other thing, Keith, is that I can, you know, look through the existing log files and just find, hey, how often would this actually do something, right? So if there's never a situation where I have 50 IPs with enough difference in the timing, you know, a couple of seconds, where it doesn't look like a script versus less than, you know, a millisecond in between, where it looks very much like somebody's running a script that hits my server, you know, this many times in the same second, thousands of times potentially, right? So this is not what's ever going to happen in a classroom situation. So yeah, there's two basic defenses against it. There's some tuning I can do on these, and there's me looking at existing log data to say, hey, if I ran the script now, how many counts would I lose? And if I manually verify those, does it look likely that those would be legitimate or illegitimate, right? So I think I'm on the right track. I need to clean this up a little bit. I need to parameterize everything. So let's just go through moving the watch items off the IDs and onto the queue IDs here. Right? So if I do this, queue ID, I think I'm going to ignore the row dates and times. I might consider them if I'm simulating things from existing log files, obviously. But for now, I think I'm just going to use server dates and times, so I don't worry about, you know, fake data getting sent through as well. We kind of want to avoid that. And in fact, IP and puzzle ID are the two things a cheater wouldn't be able to fake, because, you know, if they don't send me the right counter ID, they're not incrementing the puzzle. And the IP comes from the network stack, right? Now, they can probably hide it, like, especially if I'm not handling IPv6, I'll have to deal with that down the line. If I get a lot of cheaters that are moving to IPv6 just to increment some counters, you know, whatever. I could almost just, like, there's so many few IPv6s in my list, I could literally just assign them a random value, or just, like, group them all together and still not actually have a problem. Or just not accept IPv6, right? It would lose 0.001% of all counts, right? All right, so if we do this, and then we'll pass through QID here instead. Right. And then watch list now is an object. So if I do this, here we basically have a new watch item. And now we have to decide what data goes in here, basically. So we want a penalty level. So we're just going to have level 0. We start at 0. The timeout, we don't have a timeout, we'll just have date.now, we'll have a time like this. And finally, we'll have a counter, which just counts up how long we've been on that level, right? And then as the counter hits a certain thing, we'll go to another level, yada, 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 right? So the count will be 1, 0, because we're going to increment it here, right? So then here we're going to do dot count plus plus and dot time equals that. Right. And then if the level gets incremented or not, we'll decide afterwards. So if I do this, if defined, let's just do that. Right. So level becomes 0. Ah, yes. Let's do that. Because now, of course, our watch list is a much simpler thing-ish. Yeah. So this QID is currently at level 0 with that time in a count of 1. And if they hit more than once, the count goes up. Do we want to... I think this is fine. 1 basically means we've encountered them twice. That's not going to get confusing, for sure. I'm just going to mistake that multiple times. Okay. So then we have to basically say... So I think what we want to do is actually... we basically want to have a function that returns true or false if we have a penalty, right? So check penalty, right, for a QID. And here we'll just say if check penalty QID return, and that single call will basically do all the things, right? So if no, right. No, yeah, I guess we can do this, right? So if q index equals undefined, return false, no penalty. Else, you know, return true. Like that. Check penalty, blah, 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 blah. Okay. And here, else console.log not first time. So now we gotta find a test scenario where we have more than one watch hit. So if I go the first 5,000, the first 10,000, okay. So not first time. So here we have a guy that showed up. So these showed up twice. This showed up for the third time. Okay. So what does this look? So this will look like that. Right? And we can check how long the delta time here is. Right? So that should tell us how many milliseconds. No. Dot time. 0. So it's precisely on the same time. I guess that's very much possible. If I output date.now here. Okay, so these are like within the same millisecond. Is if I pass in the row after all. Is the row date more fine-grained? Oh, yeah. I'm an idiot. Okay. Because I'm using server time here and I'm basically simulating operation, all the dates and times are more or less the same. So probably what I want to do is I'll probably want to put in the time and then make this date.now. Like that. And then I'll pass in new date, row.date, dot value of. Right? Does that make sense? So now our time values come from the log and we can change it to being server time. And here now the difference is 1, but we actually yeah, okay, so this gotta be time. So we don't use date.now anymore unless it gets passed in as a default value. Okay, so now we have a difference of 467 milliseconds. Okay, that makes sense. Okay, and now the other, so basically, and it's not the first time, we gotta check our timeout. And this is our delta time, right? So const dt equals that, delta time. And then we'll have timeouts for the different things, right? The timeouts are part of the level. So const penalties. So for each level of penalty, we'll have a little object here, and that'll tells us what to do next, right? So in this case, we said timeout would be 5 minutes. So for example, timeout is 5 times 60 times 1000. Right? And then here, we'll say penalties, watchlist.level. All right. And then we'll just say 5 minutes times 60 is in seconds. So 300,000 milliseconds, right? Do we want millisecond accuracy here? I'm just thinking maybe we'll keep it to seconds only. I think seconds is plenty. Right. And then we can do something like const timeout equals right. Which I could only spell. So we have timeout, and we'll have dt smaller equal to timeout. False. Smaller equal dt divided by, we'll just divide by 1,000 here. Divide by 1,000. About full, round. Fine. Boom. Here we go. False. Timeout is 300. dt is that. Because I'm dividing 1 by 1,000, not both. So, here it'll be 0. Okay. So if we keep going, maybe we'll find one out where the timeout is, the difference between the two is larger. So here we got a count of 3, but the timeout is 0 each time. Okay, they're probably right next to each other. Okay, so that's another confirmation that the bad stuff is usually happening in very close succession. The bad stuff. The accidental multi-hits, basically. Ooh, okay. Now, these are all below the timeout. And now we're getting into the territory of the known bad guy, right? So, now we basically want to ramp up the levels. So, max hits, or max count was 50, right? And then we'll say, okay, as we are hitting that count, and maybe, you know, the issue right now I have is that if I'm blocking the count increments here already, if that solves if that conflicts with the classroom situation, basically, I could potentially bring this timeout down to like 5 seconds. But I don't think that's 5 seconds. I'm trying to think. If somebody writes a script that increments the count every 5 seconds, that's 12 times per minute. So that's 5 times. Sorry, it's 24 times 3600. That's our seconds per day, right? And if we say every 5 seconds, we divide that by 5. So that's still 17,000 increments per day. Yes, they run the script all day, but, you know, in 2 days, they've accomplished it. So we can't do 5 seconds. If we do 30 seconds, or we do a ramp up, but then it's just a question until they figure out what the algorithm is, right? So probably a minute is like the minimum. And there's 360 minutes in an hour, so it's like 24 times 60. So then the number is like reasonably small, that it doesn't basically hit our top list here. I mean, yeah, I'm not entirely certain how I'm going to deal with that. I mean, it's not the worst situation that many people in a classroom solving a puzzle together don't necessarily increment it, the puzzle count. But I can see the situation where somebody makes a puzzle specifically for a group activity, does the group activity, and then the counter goes up by 1, and it'll feel wrong. I'm trying to think if there's a... like, if there's a fundamental issue, like a fundamental way that I can change that, and I don't think so. I don't think there's fundamentally a difference between a script running on somebody's computer and 5 people pressing the final digit within a few seconds of each other. I mean, the only thing I guess that you could do is a longer term view of it, right? But then, you know, because I was thinking like, okay, if we're slowly ramping it up, so it's counting them initially on level 0, And as long as they don't ramp up the rate, but then we, you know, basically what I was thinking is, yes, we have that quick rate, but it's like a burst. So in a classroom scenario, that's not going to happen again, because now they're going to go move on to the next puzzle, and then for the next 5-10 minutes, they're not going to solve anything, right? So while the cheater, if he hits 50 increments, is not going to take a 5-minute break and then hit the next 50. Although that's exactly what I do sometimes when I'm exploring APIs myself. I'm just wondering if there's a sort of exponential ramp up kind of thing, right? Sort of a resistance. The problem is we still want to let things through initially. And that initial letting things through is potentially enough for a cheater to kind of get by, right? Unless we just have a, you know, my original idea was that the first n counts just go through and then we'll start blocking, right? And then if the timeout is relatively long, and it is based per puzzle, because the same person isn't going to increment the same puzzle again, right? While a cheater isn't just going to move on to another puzzle, they're going to try to increment the same puzzle again. So if they can do 50 increments, but only once a day, for example, right? Then for a cheater, that doesn't work. For a classroom, that's basically enough. Probably not per day, but let's say per hour, right? Because the next class might come in and solve the same puzzle again, right? And 50 might not be necessary. Maybe 10 is fine. Yeah, I'm also realizing I'm starting to get tired, so my brain isn't working very well. And this is a little bit of a mess right now, so I'm not really in a place of building the final version of this code. What I'm trying to think is if it's useful to have penalty levels with the similar properties that we're moving through. And I'm not sure it is. I don't think we need multiple penalty levels, right? I think there needs to be something where it's proportional to the sort of offense, right? Except that if we're resetting the timeout, it's perfectly, you know, like it's already proportional, right? So the idea is, can we allow n solves in a particular time period and then require a break to hit the timeouts again, right? And then once we're hitting the timeouts, we're just getting pushed out of the watch list. And right now, the nice thing is that this penalty check is very fast for somebody who doesn't have a penalty, right? It's literally just this. And then after the penalty check, they go in the Q index, right? And the Q index doesn't actually need to be this at all, right? So we don't need that. We don't need that. We just have that. When we're hitting check penalty, which is the second time, and we don't have anything in the watch list yet, it just means it happened within the queue thing, but it's fuzzy because that queue corresponds to an unknown period of time, which we can track. Like we can look at what is the time. We can at any moment in time we can tell how long in terms of real time the queue is. You know, basically by the time difference between the first and the last item, right? So we can say currently, like if it's busy, the queue might represent 5 minutes. If it's the dead of night or the opposite time of the CTC release, the queue might be 3 hours long, right? And that just affects coverage, because if I can make the queue longer, then, you know, our minimum coverage could still be 6 hours, and it just grows to 24 hours, but it doesn't really bother us, right? Because the memory investment is fixed. And ultimately what I want is that check penalty comes back with true or false simply if we're supposed to do the increment or not. So we're going back to the actual code. And by that, I mean the server code, which isn't here. So here, action, log object, counter increment, handle counter increment. Set puzzle ID, log object, log request. Yeah, so we're logging the event and then we're doing the increment here. So this is the increment. So this is basically where we're gonna do our check. And we might want to do the check before the log, so the log can contain information about the check. So we can log a block, basically. Because that also helps us to potentially undo something down the line, right? So I'm kindly, what I'm thinking about is kindly, does all the indexing stuff make sense? Or are we looking at a small enough number that we'll just, you know, let's see. If we, imagine we'll just have a string of, so if we're going through here, right, and we'll just say, let ID data equals string, right? And then I'll just say ID data plus equals row dot counter ID, right? And then at the end, I'll just say ID data dot length is that. Oh, wait, what? Q.shift is missing a square bracket. Here we go. Right. So, for example, the ID data length here is already 0.5 megabyte, which isn't crazy. But it's only 20,000. All right. Let us do this and also this, and then I think we have no log noise. And then if I just do this, now it gets to 1.6 megabytes for 77,000 rows, which isn't great. Megabytes of memory isn't the problem, it's just that this is a very small, simple subsystem, right? And it all adds up, right? And it's not, that's like a minimum of memory. Obviously, once it's in a data structure, it'll be slightly bigger as well. Can we look at all of these? So if we do this, we're gonna have how many log rows? We're gonna have, okay, oh, right. We have 827,000 log rows, and that's not exactly a whole month, but a good chunk of a month. And we end up with 21 megabytes. So it's not that crazy large. And we'll never have 21 megabytes. We'll have, you know, half an hour worth of stuff. So it might not be worth indexing into, you know, all of this stuff. Especially if, yeah, the thing is, it's going to get stored multiple places, right? So if instead of having a number here as part of this QID, we have the full string of the counter ID, it'll get stored here, except as a reference, but it'll get stored as a key here and in the watch list. So 2 places at least. Yeah. The other thing we could do is, what if we don't have a watch list, but it's immediately here? We just store it in the Q index, right? Because right now the Q index literally just has a 1 here, right? So what if instead of a 1, it actually has our watch object? You know, it'll start out as an empty object, but then we'll start adding things into it, right? Right. And then when we're pushing it off, we'll skip that item. I guess that makes sense. Okay, no. The reason I originally didn't do it this way was because I said I can have an arbitrary long watch list that's independent of our rolling FIFO queue stack thing, right? My God, I need to remember my terminology from university. But we already said we're going to leave the item in there because that's our trigger to even check. because every time we find an item, we're gonna skip the shift. But then when a shift happens later, it might still get shifted out, and we'll still be able to track the penalty. So somebody could be on the quote unquote shit list, excuse my French, but not be part of the last 1,000 or half hour of entries. I was just thinking, like, we could not shift, except if we're starting making exceptions for shifting, then our queue will grow. And if there's something wrong, if somebody, there could be a circumstance which just messes things up, and I don't want that. All right, so then we want a separate list. Okay. The funny thing is, does that affect our accounting for storage space for the counter IDs? It sort of does, because it means we have the counter ID at least stored in 2 or 3 places. And they are potentially quite large. They could be 20, 30 characters long, right? All right, we'll just keep the index of those. The one thing I don't have right now is I don't have a way of emptying those indexes out. So in the end of all of this, if I don't output this, if we're outputting the ID index, and then we'll do JSON.stringify.length. It'll be bigger because I'm just JSON objecting in, right? ID data. Yeah, you see it's much smaller. Wait, why is it so much smaller? Because it doesn't have the duplicates in it. Just not having the duplicates in it. Look at that, 21 megabytes versus 760 kilobytes, right? So just not having duplicates in it might mean we can have a month's worth of index of IDs all loaded. I mean, even all of them, right? Like, I know roughly, we have whatever, 250,000 puzzles, different puzzle solves, right? So 84,000 multiplied by 20 or whatever will be our limit, right? Multiplied by 10 it would be 800 kilobytes. Multiplied by 100 would be 8 megabytes, right? So if we have 100 bytes per ID and it's less than that, it would be 8 megabytes for all of them, right? So we can actually easily cache them all internally. And this is an in-memory thing. So if the server gets restarted, it just starts over. No, all the penalties are wiped, which I'm okay with. Except we could actually have our penalty list, we could write that to a file because it shouldn't change that often, right? And we don't have to update every item in there, right? We could literally have just if somebody reaches a certain level, like we could have a permanent watch list. So if somebody reaches a certain number of hits on the watch list, they go on the permanent list, and then that's just an IP ban, right? And again, it affects a feature right now that is not necessary for any operations, for anything, for enjoying the site, for nothing, right? And if one classroom out of, one classroom in a year gets accidentally banned from being able to increment the counters, it's not the end of the world either. And I'm obviously hoping that in the next year or so I will have user accounts and then all of this will go away anyways. I mean, it'll still be there for anonymous accounts. And again, for the anonymous accounts, who cares? I mean, even the permanent list, quote unquote, doesn't need to be permanent. It could be have a 24-hour timeout. It's just one that's written to a file, right? All right, I'm rambling. I think we have a really good start here. I feel like this is something I can build in a way that's self-contained enough that I can plug it in here and that I can test it out enough to be confident that it's not gonna screw things up. And we do have ways of pushing additional things into the log, so I can monitor the functioning of the system in the log and say, hey, and we can currently run it forward, but then I can also run it backwards over the existing logs. Obviously, I have some issues because there's some log backups missing, but it doesn't stop us from knowing when the counters got messed with. And the messed up counters are just for individual, it's very simple. Like I ran some scripts yesterday where I said, hey, if a counter goes up more than 5,000 in an hour, flag it, and then I manually review it, right? And that doesn't happen very often. And then I can correlate it with server traffic and actually say, hey, that makes sense or it doesn't make sense. All right, a bit of a techie session, but I feel like I'm actually writing some code that can go into server, and we've had a bit of discussions on Discord about this stuff, so this might actually be of direct interest to some of the setters, and explain some of these aberrations up here. And then these other ones, they look, they make more sense because somebody's got to be at the top, but it makes sense that the top isn't, 30% higher than the second one, right? So the fact that these are relatively close to each other, now somebody might carefully manipulate that, but less worried about that sort of thing. And a lot of these I recognize from being CTC, what's the word? Features, right? Okay, today was a bit of a toss-up between doing this one and working on a local installation of Plausible, which is the analytics system I'm using. So there is a self-hosted version of Plausible. It's open source, and I've often thought the self-hosted version might help me because I could then use it for other things than just analytics, like traffic. Like I could literally put the counter data through this system. So that's maybe something I'll look at in a stream, but maybe it's a lot of operations and like setup and stuff. So we'll see if this becomes a stream. I'll have to do it very quickly because Clemson has sponsored my Plausible membership for the last year, and it's expiring in a couple of weeks, and it's too much money. I can't afford it. And I don't want to go back to full-time Google Analytics and all that stuff. So one way or another, I got to figure this out. If I can't figure out the self-hosted version, or if it's not doing what I need it to do, I'll have to reduce some of the analytics events that I'm logging. Currently I'm trying to log every puzzle solve, and it's not because I'm using it for something, but mostly because it's exactly that I can double check it. I have an event for liking and puzzle solving and stuff that I can double check it against the internal logs. In fact, puzzle like this is the only place where this stuff is getting logged. But of course, I have a very limited number of events if I go down in the paid subscription, because right now it'll be, I don't know, a couple $100 per month, which I can't justify. But if I go down a couple of levels, maybe I'll get rid of some of these. Like, let's see, if I go last 91 days, just to get an idea. Yeah, like I might have to stop tracking the puzzle solved event until I can figure out a different solutions, right? Or maybe some of the ad tracking, although the ad tracking is kind of important. Visit Fog Novella. What was that again? Yeah, I've got some custom stuff in there. All right. Anywho, thanks for hanging out. That's it, actually. Thanks for hanging out, Keith and Flinty. And who else stopped by? Just you two guys. All right. Well, the more the merrier, but 2 is better than me being alone here. So, look for kitten there, from puzzle with kitten in it. Yeah, here I was just testing kind of. Yeah, eventually I'll have to test it with real things. I'm gonna see if I can run it in parallel without actually doing anything, just maybe writing into a completely independent log file somehow. We'll try it, and then basically say, hey, or maybe adding to this, adding some extra data saying, hey, this should be blocked because of the thing or whatever, right? And then just watch it for a while, see how many of these happen in the logs, and then after a week or so, switch it on. In the meantime, I just typed this somewhere. I don't know where I was typing. Nope, wasn't here. All right, well, thanks for hanging out. It's always better to do something with people instead of on your own. And in the meantime, take care. Have a good one. Hope to see you guys in the next stream. And say hi on the Discord and or in my emails. And have a good rest of your day.